Hi class, let's take a look at example 4. In example 4, it appears that it's going to be a little bit messy just because of the actual function that we're given. And then the limits are going to be from 1 to 3. So let me just put the formula. I think this one will be easier to actually evaluate pieces of it on the side. So we're going to end up evaluating the integral. This is from 1 to 3 of the square root of 1 plus technically f prime of x technically squared dx. And then let me start doing this one on the side. So we're going to let f of x equal to 112 x to the third plus x to the negative 1. And f prime of x, it's going to be technically 3/12 x squared minus x to the negative 2. And let's simplify this as much as we can. So we're looking at x squared over 4 minus x to the negative 2. That is, in fact, let me fix this. It's a 4. So that would be the derivative. And let me do the squared portion before we actually plug it in into the square root. Otherwise it'll be very messy. So f prime of x and technically squared actually means, well, x squared over 4 minus x to the negative 2 squared, which means that we're multiplying an x squared over 4 minus x to the negative 2, x squared over 4 minus x to the negative 2, which is going to give us an x to the 4 over 16. And technically, as we multiplied, so careful with the exponents, as we multiplied this x squared over 4 times negative x to the negative 2, that one is going to simplify to just negative 1/4. And then we have a negative 1/4 again, and then plus a x to the negative 4. So this one simplifies as x to the 4th over 16 minus 1/2 plus x to the negative 4. That happens to be equivalent to technically f prime of x. Now, mostly all of these problems, once you add the constant, you should be able to factor. So far I'm just doing all the bits that happens to be inside of the square root separately. So I'm now going to try to do 1 plus f prime of x technically squared. So this is going to be 1 plus x to the 4th over 16 minus the 1/2 plus x to the negative 4th, which is going to be, well, x to the 4th over 16 plus 1/2 plus x to the negative 4. I'm just adding the 1 and the negative 1/2. Okay, so our next attempt here, and this is because, well, a u doesn't seem to actually work, is try to see if this one factors. Now, there's no guarantee it's going to factor, and then you don't want it to factor into any two values. We want them to factor into a perfect square. So we're looking at well, x to the 4th over 16 plus 1/2 plus x to the negative 4. It's going to be equal to, and we're looking at the next two factors. So this has to be an x squared and an x squared, and then technically a 4 at the bottom. And then since we have a plus on both of those, that would be a plus x to the negative 2 and plus x to the negative 2. And then check it. If you multiply technically these two, you're gonna get x to the 4 over 16. And then if you multiply this one times that one, it's gonna give us, it's gonna cancel the x's. So plus 1/4. This will be plus your other 1/4. And then plus your x to the negative 4. These two are gonna give us the 1/2. So this one does factor. And the most important portion is that it's actually factoring as, well, two identical terms, or it's a perfect squared. So x squared over 4 plus x to the negative 2, technically squared. And then we can finally go back to the formula. In this case, I'm going to go back to that formula. And then we're going to have that L is equal to the integral from 1 to 3 of the square root of 1 plus f prime of x, technically squared, dx, which is equal to the integral from 1 to 3 of the square root of technically x squared over 4 plus x to the negative 2, and then we technically have that squared dx. Now there's no guarantee that this is actually gonna work on all of them, but it's sort of a pattern that you're gonna see in this section. Some weird factorization that, well, it's going to occur as you add the 1 to the actual derivative squared, which in this case it actually works out very nicely because it's going to be a little bit messy with the fractions, but we're just looking at the integral from 1 to 3 of x squared over 4 plus x to the negative 2 dx. And then from here, let me evaluate the integral. So the square roots and the squared cancel. And then we're looking at the following from here. So the first one's going to be x to the third divided by 12. And then technically just a minus x to the negative 1 because we're adding 1. Yep. And then we're evaluating from 1 to 3, which it's going to be a 3 to the third over 12 minus 3 to the negative 1 minus a 1/12 minus technically 1. So let me see if I didn't mess up this somewhere. No, so this one's going to be 27 over 12 minus 1/3 minus 1/12 minus 1. Whoops, it'll be plus 1 because we're distributing out the negative to those two. Okay, so let me combine the like terms. So we're looking at this one being 26 over 12 minus 1/3 plus 1. Actually, this one reduces because it's 26. We can divide it by 2. And we end up with 13/6 minus a third plus 1 with an LCD of 6. So multiply times 2 times 2 times 6 and times 6. So we're looking at 13/6 minus 2 6s plus 6 6s. So I'm looking at, well, that would just be 4, 17 6s. Okay, let me double check because, well, it was a little bit long. But in this case, we're looking at L is equal to 17 6s which is going to be technically be units, and as a decimal approximation at 2.8. Okay, 17, or yep, that's actually it. Okay, so a little bit messy. Like I said, these problems, it's the factorization that may take a while, especially the factorization will never occur if there's an algebra error somewhere. That's it for this one.